In this video we are going to discuss about laser processing and chemical vapor deposition method. The laser is the effective method that we can able to deposit a material. The the laser floating zone, that is LF, is that technique allows the growing materials which high melting temperature. So usually the laser has a high pointed source, and it is a coherent source though, so the light rays will be traveling in a straight line. It produces a high melting temperature due to the narrow focus of the laser beam. So because of the pointed source, every electron or photon that will be concentrated and focused on the same position, so that it has an effective method for the laser. It enables the growth of a single crystalline light texture. This method induces polycrystalline materials and amorphous materials. For the crystallinity materials, we can use many other methods to. Amorphous materials having a irregular shape. So for that irregular shape, we have to do. Polycrystalline material, so we can use the laser chemical vapor deposition method. So the absence of crucial LFS avoids the usual combinations due to the reaction of molten materials. So when the laser floating zone is pointed on a amorphous material, it reacts of the material and become a molten stage. So that molten stages like a rod like fiber shape, they will be grown. So it's used to observe the energy. So we can see the we can see the laser. We can see the laser. Pulsed laser of a Nd:YAG laser. So an allotted system of surface treatments is based on the Nd:YAG laser. So the Nd:YAG is a very powerful laser. That is a 3-level laser having a very good efficiency of breaking the component into simpler structure. For the power unit, there will be a consisting of a power unit and a cooling system, the calorimeter head and the moving table. The later that allowing the sample to control the speed of 10 to the power minus 1 meter per second. So in the closed loop, the water cooled plus pulse laser emits a fundamental wavelength. That the wavelength is nothing but 1064 nanometer, which is above the red nanometer. The red nanometer is 600 to 700 nanometer. So above that means that it will having a more power. So the power will be a average of 100 volt. So those the pulse frequency from of a 4 to 30 kilohertz. So the software driven galvanometric, the galvanometer reading will be shown there. So this is the chemical vapor deposition of a pulsed Nd:YAG. Thank you.